Hello everyone. Now we are starting numericals of this chapter AC circuits. So first let's take the basic numerical number 12. It is given that effective current in a 50 cycle AC circuit is 5 ampere. So effective current here means it is the value of IRMS, which is 5 ampere. Then 50 cycle, so this is your frequency 50 hertz. What is the peak value of current? So we are supposed to find the maximum current, which we know it is denoted by I naught, and then what is the current 1/600 second after it was 0. So they have asked you again instantaneous current I का value पूछा है and time they have given is equal to 1/600 second. So कौन सा formula use होगा? I hope you have seen lecture number 4. In that we had derived one formula between IRMS and maximum current. It was IRMS is equal to I naught divided by root 2. So therefore I naught can be written as IRMS into root 2. Just substitute the value 5 into root 2 ka value 1.414, and when you multiply this you will get 7.07 ampere. Okay, now we are aware of this formula, instantaneous current का formula I is equal to I naught sin omega t. familiar formula है, काफी टाइम यूज किया है. ओमेगा के बदले हम सब्स्टिट्यूट करेंगे 2 pi f like this. Now we are just supposed to substitute the values. I naught का value मिल चुका है, time 1/600, frequency 50, and when we solve we'll get the final answer of current after 1/600 second. So let's substitute. I naught का value है 7.07 sin 2 into pi into 50, and this is 1/600. 5 ones are 5, 12s are 2 ones are 2, 6 are. So जरा ऑब्जर्व करो, here we have sin pi by 6. Pi by 6 is nothing but 30 degree. So sin 30 is half. ठीक है, so इसका half कर दो, you will get answer as 3.535 ampere. Okay, so let's move on to the next numerical number 13. You can observe we have a light bulb whose power is given as 100 watt. So P is equal to 100 watt and it is supplied with 220 volt AC. Now ये जो EMF है, this will always be your RMS EMF. Unless peak value दिया है, all other values of EMF will be called as ERMS. Okay? 50 hertz, so frequency is 50 hertz. They have asked you to calculate the resistance as well as they have asked you to calculate RMS current. Now क्वेश्चन से इतना समझ गया कि ये सर्किट में सिर्फ रेजिस्टेंस इन्वॉल्व है, इंडक्टेंस कैपेसिटेंस नहीं है. ओके, सो आई होप यू हैव रेफर्ड द लेक्चर नंबर 13 फॉर एवरेज पावर इन केस ऑफ रेजिस्टेंस ओनली. उधर हमने एक फॉर्मूला सीखा है एवरेज पावर का, व्हिच इज ERMS इनटू IRMS. सो बस वैल्यू सब्स्टिट्यूट कर लो. हियर यू विल हैव 100 is equal to 220 into IRMS. So therefore IRMS will be 100 divided by 220. This will give you 5/11 and which will give you as 0.4545 ampere. Okay, so एक आंसर तो मिल गया. Now रेजिस्टेंस फाइंड करना है तो सिंपल ओम्स लॉ लगा दो. We know it is E is equal to I into R. अब E और I का वैल्यू कौन सा लेंगे? RMS का ही लेंगे. Okay, so that is how R will be becoming ERMS divided by I RMS. Now I am easing your calculation part. E का value है 220. I RMS I will not substitute this decimal, otherwise log calculation में जाना पड़ेगा. I will substitute directly this part. Okay, so that is 100 divided by 220. अब आपको समझेगा इसका फायदा क्या है. So next step will become ये 220 numerator में जाएगा. So that will give you 220 square divided by 100. अब 22 का square तो आपको पता ही होगा. You all are genius at maths. So 22 का square है 484 and this double zeros. Okay, divided by 100. So this got cancelled and we got final answer as 484 ohm. So this is the way to ease your calculation in a shortest way. Okay. So let's move on to the next sum, which is number 16. Alternating EMF का equation दिया हुआ है, which I'll write it as it is. E is equal to 220 sin 100 pi t. So इसको अगर आप compare करोगे ये equation से, E is equal to E naught sin 2 pi f t. तो आपको इसमें E naught का value मिल जाएगा. You can observe E naught is equal to 220, whereas 2 pi f का value कितना है 100 pi. ये सब यूज होने वाला है. Let's try to understand the next part. And उसमें इंडक्टेंस का वैल्यू दिया है 1 by pi. So I'll write L as 1 upon pi. And they have asked you to write the equation for instantaneous current. मतलब वही I is equal to I naught sin 2 pi f t. ऐसे ही टर्म्स में लिखना है. So अगर वो टर्म्स में आपको इक्वेशन लिखना है तो कहीं ना कहीं I naught का वैल्यू लगेगा. So that is how. First thing is you are supposed to find the value of I naught. तो ये तो आप instantaneous current का equation लिख पाओगे. Secondly, what they have asked, the reading of galvanometer connected in the circuit. So galvanometer क्या बताता है? It detects the presence of current. So कहीं ना कहीं current का ही value पूछा है. अब ये कौन सा current होगा? Definitely it will be your RMS current, which can be measured by galvanometer. Okay, so let's try to solve this. I hope you have referred my lecture number 7 on inductor. ठीक है, so उसमें एक फॉर्मूला सीखा हम लोग ने, which is regarding XL, inductive reactance. क्या है इसका फॉर्मूला? 2 pi f n. अब हमको ओम्स लॉ पता है, which is E is equal to I into R. बट इंडक्टेंस हो तो R के बदले क्या यूज करते हैं हम लोग? इंडक्टिव रिएक्टेंस. रेजिस्टेंस के बदले इंडक्टिव रिएक्टेंस XL. एंड इधर हम मैक्सिमम करंट ले लेंगे, मैक्सिमम EMF ले लेंगे. सो इससे कहीं ना कहीं हमको I naught का वैल्यू मिल सकता है. So let's solve this. Therefore I naught is equal to E naught upon XL. चलो वैल्यू सब्स्टिट्यूट कर दो. E naught का वैल्यू है 220, XL के बदले 2 into pi into f into L. Now what I'll do, instead of 2 pi f, we know the value is 100 pi. Instead of L, the value is 1 upon pi. Okay? So pi got cancelled. 22 divided by 10. This will give you answer as 2.2 एम्पियर. अब आप इक्वेशन लिख सकते हो, which is I is equal to I naught sin omega t. Omega will be written as 2 pi f t. One interesting part over here. इंडक्टेंस में करंट EMF से पीछे चलता है by angle pi by 2. It lags by angle pi by 2. So यहाँ पर minus pi by 2 इंक्लूड करना बहुत जरूरी है. बस वैल्यू सब्स्टिट्यूट कर दो. सो योर दिस पार्ट इज डन. इंस्टेंटेनियस करंट का इक्वेशन मिल जाएगा. सो देयरफॉर आई राइट I is equal to I naught is 2.2 sin 2 pi f is 100 pi t minus pi by 2. One part is done. Second part तो बहुत easy है. You know I RMS is I naught divided by root 2. I naught value is 2.2 divided by 1.414. अब डायरेक्टली डिवाइड कर सकते हो, अदरवाइज टू ईज योर कैलकुलेशन, थोड़ा इजी करने के लिए हम क्या कर सकते हैं, रूट 2 से मल्टीप्लाई कर दो numerator as well as denominator. So this will become your 2. So 2 ones are, and this will be 1.1. Now you can directly multiply 1.1 into root 2 का value 1.414. ये directly multiply करोगे, so you will get answer as 1.555 ampere. Okay, so that is how this sum is done. Thank you.